Hey everybody, this is Larry. This is me going Q3 of the bi-weekly contest 113. Count pairs of points with distance K. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. This one may be one of the trickier problems for Q3 if you haven't seen it before. I think one thing that I kind of would like to teach in general is about progression, right? And for this one, this is what I like to call prefix sum dynamic programming or prefix dynamic programming. There are a couple of problems with this, and also a couple of problems on Leetcode that are similar. I don't have a list right now, but definitely ask in the comments or in the Discord, and we can kind of just figure it out. But they kind of have the thing of count pairs of blah 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 blah, right? Like count pairs of stuff, but in a way such that n squared is not possible. And in this case, n is 50,000, so n squared is not possible, right? And there are a couple of techniques that that you kind of see over time, but the biggest thing is just the dynamic programming portion. The idea being that you're just trying to find something in the past that you've seen before, and every move you do is going to be, I want to say, constant or some basically cheap enough, right? Because you're and able to aggregate in a quick way. And what I mean by that is that n squared is simple and naive and quick to implement, but of course it's going to be too slow. So the idea here is that you're able to kind of have a cheap operation to look at as you kind of process a number at a time to aggregate all the things that you've seen in a very quick way, right? And there are a couple of problems, like I said about this one. Like the very basic one would be like, count number of pairs where the sum is equal to k, right? So like basically this, but without this funky formula. We'll go over that in a second. But in that case, then now your formula would be something like, let's say you're trying to find two numbers, like I said, a pair of numbers that sums to some number k. So then now you have some x plus y is x plus y is 0 to k for some k. Your current number is x, and you're trying to find y, right? So what would be y? Well, y would just then be y is equal to k minus x. Hopefully this part makes sense, because and then now you're trying to find how many instances of y you've seen in the past, and you could do that with a hash table, a frequency table, to look up how many times you've seen it, and that's the only number you care for this particular problem. So, and there are more advanced version of this where sometimes they want you to do something like a1 plus b1 is equal to a2 plus b2 or something like this, or how do they write it sometimes? Oh, actually, I think very similar to this particular problem, actually. Sometimes they actually write it something like this, where for a pair of numbers a1, b1, you may get this formula where you're kind of commingling, but then you just kind of, the right way to think about it is rewriting this formula so that you bucket the indexes together. This is a little bit yucky, but something like this, and then now now you're just kind of reducing this to k is equal to 0, but for this, and then you also just have so now you have this, and then you do some lookup table magic, right, like we said. So this problem is a little bit different, right? For this particular problem, you have this formula, right? Is equal to exactly k, right? And we're trying to find out how many instances that we've seen, right? The key thing to note, and it took me a little bit of time to be frank, is noticing that k is only 100. So I was trying to figure out how to kind of brute force it in a smart way. That's whenever I see a small k, that's how I try to do it. Or it maybe brute force in a smart way, but in some way maybe that is important, maybe not. Sometimes there's a red herring, they're trying to fool you or something. But it is something to consider if you get stuck. But yeah, but basically you have this formula that you're trying to do, and you're given x2 and y2, and you're trying to find some previous x1, x2. On a first glance, you look at this and you're like, well, this doesn't really apply. And to be honest, I was trying to figure out how to do this trick, if you will. You want to call it a trick of just bucketing it so that you have the same size. But I wasn't able to do it because XOR isn't really an operator that you can do it to, or at least with respect to, you have to add between two different things. I couldn't really separate out the equation to one side and left side. If that was the case, that would be much easier, right? You can imagine if it was something like x, this is a normal addition, this is a normal addition, then you could just easily subtract x2 and y2 and on this side, and then you can look it up. But so what I thought was, okay, well, k is small, then what happens? Well, now, and this is an addition problem, and what is the domain of these of the components of the addition, right? Well, this XOR, given that x1 and x2 can only be a positive number, then XOR is also going to be a positive number. I actually don't know how XOR and negative numbers work. I mean, I know stuff about 2's complement and stuff like this, but so I know how it works mechanically, but I'm curious how that works mathematically. Anyway, it's not relevant for this problem. But you know that this is positive, this operation is going to be positive, so this is a positive number, right? And same thing for this side, this is going to be a positive number. What does that mean, right, for us? Well, what that means is that because k is small, we can just brute force this. So basically, the idea is that I'm going to just call this x and this part y, just for now. And then, so that means x plus y is equal to k. So we brute force x is equal to 0, y is equal to k. And then we brute force x is equal to 1, y is equal to k minus 1, right? And x plus y is still k. And dot, 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 you could kind of draw the lines now. X is equal to k, y is equal to 0, right? And what does that do for us? Well, if this is the case, then we can go, okay, now we can solve for it, right? So, for example, this is equal to k, right? What does this mean? Right? Let's not use k. Let me say k sub 1, right? Or k sub x, okay? Right, so let's say we have this formula, and then now we have this number and we have this number, so now we only have one unknown in this formula, so we have to find x1. We're given x2 because that's the current progression, just by that. So then now we have to move the x2 to the other side, so then now x1 is equal to k sub x XOR x2, right? And now in this case, we're given this, we know what this is, well, just because we brute force it. So then now we could count this, and then we also do that with the intersection of the right side, which is y1. Let's make it slightly consistent. K sub y, right? And then now y sub 1 is equal to k sub y XOR y sub 2, right? So that's basically the idea, is that now we can count all these in aggregate and then solve the problem that way. So that's basically the idea. And again, I'm not really going over the dynamic programming portion because there are a lot of problems that deal with that, and I probably have videos that kind of talk about it in more detail. But basically that's the idea, right? Is that as you kind of process this current number, how many pairs can it make with numbers to the left? That's all it's asking, and that's how I write it. Yeah, so this is basically my solution. These are the coordinates that we've seen. This is the answer that we're returning. And then for xy, for every coordinate, we try to calculate, I guess this is what I call k sub x here. But I did d for distance or delta actually, right? So yeah. And then now So x1 has to be this number if we're given this case of x. Y1 has to be this number given this case of y. So now we're just trying to find, I missed a step, what are the coordinates of x1, y1 and count the number of them. And that's basically what I do here. This is the XOR, this is x1, this is y1, and then we just kind of find, we do an addition to kind of do the math. And then after that, we tell the map that we've seen x and y. So that's basically it. This is linear time, linear space, and yeah. Linear times k, so maybe pseudo-linear if you want to call it more specifically. I forgot about a k, my bad. I did actually spend a little bit of time during the contest, during the virtual contest, confused because I thought it was going to be k squared. I just was bad at math / just woke up. That's my excuse. But yeah, I think the other thing was, and you can watch me solve it live during the contest, but I did solve this, I think, within the 10 minutes. I think the 8 minutes of this was because the server was having issue. I didn't submit. And then it kind of, I don't know, went out of range. But definitely check that out if you're curious, because I did kind of, I don't know. Let me know if that's helpful. That's all I have. Let me know what you think. You can watch me solve it live during the virtual contest now. Right, let's just YOLO it. That'd be very sad if I'm still missing. Okay. Still get a wrong answer after the testing would be the worst part. But alright. 2D integer array coordinates. Okay. Distance is an XOR distance? That's weird. N is 50,000, so you can't do any n square. Number of pairs such that I is less than j. That's fine. And the distance is equal to equal to k. Equal makes it a little bit easier, right? I mean, it's gonna be dp, but how do you separate a map? To the 6. Oh, k is 100. I just noticed that. What does it mean by k is equal to 100? That means you could prove force for each one, maybe? No, does that make sense? No. K is equal to 100. How can you bucket it? Well, k equals to 100 means what does that mean? That means that, what's it, 5, 6, 7 bits. At most 7 bits. But it's 2 to the 7. Another tricky one. Can you do TP on this? There's stuff about the prefix maybe, but to kind of narrow it down, but in theory I guess it doesn't matter that much. Huh. Can I brute force this? 0 is easy. 1 would be 1 bit. That's different. 2 would be that's the problem, right? If k is 2, you have 1 plus 1. So then for each number you have 100 times 100 would be a little bit tricky to look up. 10,000. $10,000 times 50,000 is definitely way too much. Wow. No, what am I thinking about? Why am I saying to 100 square? It should be just 100, right? 100 times 50,000 is still pretty slow though, but yeah, using Python. We'll see how that goes, I guess. Because that's like 5 million. 5 million lookup. I guess we'll see. They make the bounce so annoying for Python. Yeah, we'll see. I mean, if I have to rewrite this in C++, I guess this is just Leetcode. I blame on Leetcode. I guess X and Y is something. Oh, I said it. Right, so then now for X, Y, let's for zero to k, k minus xt, right? So then now, okay, we have a count. If like this, right? Unknown error. I guess this is like the real contest simulator. Even in VC, I cannot get a thing going. Is it me? Like, even in VC, we cannot get a clean contest. Alright, so that's not me. We just pretend one. Come on, friends. What are we doing here? Oh, there we go. We're finished. I was just pulling up something. 3 and 30? No, that's not. That's just way wrong. Why is that wrong? Oh, because do we count duplicates? No. Okay, is 0. This is 0, 1 times 1. Oh, it's not. This is not a times. This should be like a set intersection. I thought I could write it this way, but I was wrong. Okay, so then now just maybe something like. Okay. I got it. It's not that bad. But I don't know why I made this optimization. I just was worried about it. I mean, this is a very awkward thing to do in general, but it should only have 50,000 copies, so it should be okay, maybe. I don't know why I would. Oh, wait, no. Come on, server. I mean, should I just skip ahead? Leetcode having issues is, I guess, the real Leetcode experience. Alright, I think this is right, but now we have to look at another problem. I mean, it may time out just because Python is Python, but we should be okay. But it would be more okay if we if Leetcode works. Should I just skip ahead? Alright, I'm just gonna skip ahead, and if it still doesn't work, it is what it is. Minimum attributes so that every. I can't even run this, can't I? I was gonna just like run it for to see. Oh, there you go. Alright, maybe I could submit it now. Okay, so I mean, we had so much more time, but okay. I was gonna say we can run this to kind of see an example to see how my code is doing, but I guess actually we maybe came back just in time, even if it kind of tilted me for like a couple of minutes. I don't know how long it took, but thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and the problems and everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.